Right. Cisco Certified Network Associate, CCNA, routing and switching. But initially, we need to see how the network was evolved, how network started, and what all the devices were there in past and what do we have in present. Network, initially when they designed for communication between the soldiers, between the army leaders, a secret communication which no one can see. That was the main idea behind when they decided to have a network. But later it is given to everyone. Now every one of us use the network. But initially it was not meant for the entire world when they designed it. Now we have network. And initial days there were some devices like this. Amplifier. Amplifier is a device that amplifies the data, the signal that we send. We know that when a computer, let's say A, talks to another computer, let's say B, means communicates, when it sends any traffic over the wire, over the cable, they send in bits and bytes, zeros and ones, all electrical signal. You might have learned in colleges, on and off. Off means 0, on means 1. So our data goes from one place to another. Even as I'm talking to you, you are hearing my voice and seeing my screen. All these are coming in this zeros and ones, one format. But when I speak to you, you can hear me very clearly as if you are in a classroom environment. It is possible because of various devices. One of the device is amplifier. The job of amplifier is to amplify the signal. You see, if I don't have a mic and this internet, even if I shout from here, no one is going to hear in my next street. Right next street, no one can hear me. Then how you will hear many thousands of kilometers away? It's not possible. So the atmosphere, the air has got resistance. So when I speak, that resistance minimizes the coverage area of my voice. My voice cannot reach from here to US without these medias, internet and mic and so on. Likewise, every media in internet also has got limitation. Like air has got some limitation. When you speak, you need to speak louder if you are talking to 50 people. If you're speaking to just 5 people, not much louder. Why you do that? So that you can overcome the resistance that is there in the air. Same way, every media, see, this wire has got some limitation. There are some wires that supports only 100 meter. There are some wires that supports 300 meter. There are different types of media with different capacity or with different limitation. Let's assume we have a cable that supports only 100 meter. What if I have a device behind 100 meter? See, A and B are not in 100 meter. Let's say A to B is 175 meter away. 175 meter away. But the wire that you have supports only 100 meter. Which means anyone behind 100 meter will not get all that A sends. So whatever A sends, B may not be receiving everything. Why? This wire has got some resistance. It has got some opposing impurities in the wire inside. The copper wire inside has got some impurities. Because of that, there is resistance. Because of resistance, data cannot travel for long distance. So there is a limitation in the coverage area, whether it is Wi-Fi or wire. There is a limitation. Now let's talk about the olden days. Olden days, there was no Wi-Fi, there was no Bluetooth. They were dependent on wires like Ethernet wire. We call it as Ethernet. Ethernet is a standard. You don't ask what is Wi-Fi. You know what is Wi-Fi. When someone says Wi-Fi, you know what is Wi-Fi. Same way, you should not ask what is Ethernet. Like Wi-Fi, this is another standard, right? So now, this cable has got some limitation of 100 meter, let's say. How do you now reach A to B? By adding this box, the junction box, the amplifier, somewhere in the middle. So we take this box amplifier, we keep it in the middle. So when we keep it, what happens is the signal that is getting weaker will be strengthened again. Say for example, A is sending signal and it is slowly becoming weaker, and the amplifier gets the weak signal and amplifies it back to a strong signal. It gets more strength. The signal gets more strength because of amplifier. Signal has become more strong, and now B can receive the data that is sent from A, or A can reach B, and vice versa. So amplifier was found good to send data to a large distance. But the problem with amplifier is this. The problem is amplifier will amplify everything that comes in. What happens, on the roadside, you will have some transformers, the electrical post, and also the magnetic field of the gravity. Earth has got magnet, Earth has got gravity. Due to gravity also, some data getting added in the middle. This is not the data that you sent. This is the data which is automatically generated on the wire because of the external magnetic force and electric force. Now what happens when this error along with the data, we call this as noise actually. We don't call it as error, we call it as noise. When this noise and data get inside the amplifier, even the noise get amplified. So when B receives the data, he is not just receiving the data that was sent by A, he receives something more like symbols that you can't understand, some special characters that we don't use. So B is not just receiving the message that A sent, he is also receiving some symbols, some alphabet, some lot of unwanted thing which really was not sent by A. Actually A might have sent hi, how are you, I am good, hope you are doing good, that's all. But B, when he receives, he is receiving something more than what was sent by A, and he don't really understand anything out of it because it is full of this junks, the noise mixed along with the data. Amplifier's job is to amplify anything that comes in. You cannot avoid, because amplifier don't know how to avoid it. Amplifier, it just amplifies anything that comes in. That is the job of the amplifier. You give me, I'll make it big, that's all. Whatever you give me, I'll make it big. So whatever comes in, its job is to magnify it, amplify it. So it was amplifying it. But it is no good for us. It's not at all useful when we have a lot of noise mixed with the data, unwanted messages. Sometimes we don't understand anything out of those communication. So what they did is, They designed a box, as you expected, they designed a box that can identify the noise alone and filter the noise. And that is what we call it as repeater. Repeater. So repeater is a device same like amplifier, but the good news is it regenerates only the data. It regenerates only the signal. So when you have A sending something to B and you got repeater instead of amplifier, when we when we replace repeater in the place of amplifier, what happens is the repeater, when noise comes along with the data, let's say our noise get added here, the repeater can identify the noise and regenerates only the actual data, and B receives now the actual data. Nothing added. So repeater has got that intellectual to filter out the noise and regenerate only those signals sent by A. Good. So repeater is good. No one uses amplifier. Repeater is good than amplifier. Yeah. Yes. We are repeater is not used in company. It is used in between two different location of a city. Say for example, you have a part of a city, let's say South Hyderabad, North Hyderabad, and between these two there is no much buildings. From South to North Hyderabad you need to take the data. So what they do is in the middle on the way they keep lot of repeaters, so that from north to south and south to north the data can pass through. Now here in Bangalore also we have those repeaters here and there. So you will be seeing some kind of a big bulb kind of thing in black color hanging on the roadside. That is what repeater for the right. Now after repeater comes something called a hub. Hub is another device, another network device. Now what is the difference between repeater and hub? Hub is a multi-port repeater. Hub is also a repeater, but it has got multiple ports. Multi-ports. Why hub is called a multi-port repeater? Here the repeater has got just two ports. When I want to connect the third, see I have just drawn a computer, but let's say North Hyderabad, South Hyderabad. If I want to connect the East Hyderabad to this network, so if I want to connect North, South and East Hyderabad, there is no port for East Hyderabad to connect. You got just two ports. You can connect one network and the other network. That's all. The third network you cannot connect to the repeater, or you cannot connect the third device to the network. Only two devices. Only. Yeah, we call it as port. Okay, we call it as port. The port is the place where we connect the wire. You see, let me show you some pictures of those devices. So this small rectangle here, they mean, hub, port here, port. So hub can have more number of port, but the repeater is only 2 ports. What is the function of repeater? It regenerates the actual data. Is that right? It filters out noise. That's what we learned. Hub is a multi-port repeater, meaning it does everything same like a repeater. It filters noise, it regenerates signal. One plus point is one additional thing is it has got more ports. So hub is a multi-port repeater. Multi-port repeater. Device with more number of ports. Okay. How many ports? If it has got multi-port, how many ports? The maximum number of port hub supports is only 8. 8 is the maximum number of port. Hub has got 8 port. Repeater has got only 2 ports. Right. Now, there is a drawback with the hub. So we have another device called a repeater. What is the drawback with the hub? The drawback is hub is not that intellectual, not that intelligent. Meaning what? Let's say you have a 8-port hub. Let me draw. One, two, three, 4, 5, 6, 7, and 8. And I got some computer, let's say A is connected, B is connected, C is connected, so we got 8 devices connected. Now this 8 device, whenever any device communicates to other device, all 8 devices will get the message. That's the issue with this. See, repeating again. Whenever A wants to talk to C, whenever A communicates to C, the packet not just goes to C, the packet goes to B, D, everyone. Everyone. The reason why this happens is hub never learns the computers that are connected to it. See, every computer has got a name. We call it as MAC address. See, A, B, C, D, E, F, G, H. Assume it as MAC address of those computers. So MAC address is nothing but name given to that device. It's a name to identify the device. Every device have got MAC address. Now the hub don't have that capacity, the knowledge, the intellectual to learn the MAC address of the device. Let's say this is port 0, port 1, port 2, port 3. Port 4, 5, 6 and 7. So totally you got 8 ports from 0 to 7. Hub never learns that F is connected to port 5. It don't learn. It never learns. It never learns that C is connected to port 2. Learning the MAC address, learning who is where, you know. Whereas repeater learns it. Repeater maintains a table. Let's say this port is 0, port 1, port 2, port 3, 4, 5, 6, 7 as we discussed before. Now, repeater, initially the table will be empty. Nothing in the table. Initially, sorry, not repeater, right? Did I say repeater? Oh, sorry, this is repeater. Bridge. I'm talking about bridge. After hub comes bridge. I'm sorry, it was my mistake. Bridge. It is not repeater. Bridge. So bridge is an intelligent device. How it is intelligent device? What it does is when A talks to C, A is sending a packet saying, hey, it's me talking. Sending. Who is sending here? A is sending. We call it a source. Packet is going from source A to the destination C. When this packet hits the port, when the packet from this computer, this packet is coming from this computer through this wire, it is going and hitting the port. Bridge learns that there is someone called A connected on port 0. How it learns? From the source. What is source? The one who is sending. So if I know the MAC address of the sender, I know the sender itself. That's the name given to that sender. Now, one second, I'll make this clear. A is sending to C. Source is A, destination is C. When this packet comes inside the port and hits the port from the computer, it learns that there is someone called A. On which port it is receiving? It is receiving on P0. It learns that there is someone called A connected to P0. Is a name to identify the port. The computer has got an address called MAC address. This is different. This is the port to be identified. See, as you are coming to say, even the device, the bridge port also has got a MAC address. I'm not talking about the MAC address of the port. I'm talking about the port identification. See, you have a switchboard in your home and you say put the first switch. What does it mean? The first switch here. Put the fourth switch. What does it mean? You mean that fourth switch. Fourth switch is, this is fourth, this is first, this is second, this is third. You have switchboard right in the home to put the lights and fan, to turn it on and turn it off. Same like, as you number the switchboard, here it is numbered. The ports are numbered. So every port is identified with some number. P0, P1, P2. Now, where is C? C is somewhere. According to you, you know C is in P2, correct? On P2, C is connected. But initially, bridge will not know where is C. Because so far no communication happened, it didn't learn. So what it does is it sends this packet to everyone. It is going to B, it is going to C, it is going to D, it goes to everyone. And then C responds saying, hey, it's me, C. The packet you sent it is to me. So when C responds back to A, source is C and destination is A. Let me repeat again. See, A is talking to C and C is replying back to A. That is what we are trying to understand. A, when it wants to talk to C, is there any information about C here in the table? No. What it does, if there is no information, it will send it to everyone. And the C, which receives the packet, and the C, which is also one among everyone, responds back. This is response. C talking back to A. You say hi to me and I say back hi to you. So when you said hi to me, you are the source, I am the destination. When I say hi back to you, I am the source, you are the destination. So here the source and destination, and this destination has become a source now, and the source has become destination, the reply packet. Now when the reply packet comes, this is what source coming from, the reply is coming from C, and it wants to reply to A. When this packet hits the port, what this bridge will do, you know, this bridge will learn that there is someone called someone called C connected to P2. Do you understand what I'm coming to say? Bridges can learn the MAC address. After a point of time, it knows that B is connected to P1 and D is connected to P3, E is connected to P4, and so on. It learns everyone who are connected to this bridge. Bridge is an intelligent device. It can learn the MAC addresses of the devices connected to it. What is the advantage? Advantage is whenever A wants to talk to D, packet goes to the bridge. Bridge looks into D. D is in bridge, looks into the table. It says D is in P3. So the packet goes only to P3. It is not going to everyone. Correct. Because hub don't learn MAC addresses, always every packet will be sent to everyone. That is the disadvantage of hub. Hub will always broadcast. Why it needs to broadcast? Because it don't learn any MAC addresses of the devices that are connected to hub. Hub don't learn MAC addresses of the devices that are connected. Because they don't learn, they need to send the packet to everyone all the time. They always broadcast. Hub always broadcast. Whereas bridge, initially it will broadcast to learn before it learns the MAC addresses against the port. Before it learns the MAC address, it will broadcast. But once it has learned, it will do wait, let me give you one more quick review on bridge. You see, right, correct. So if A wants to send it to D, it goes only to D. But initially, when this MAC address table, we call it as MAC address table. MAC address, the table in which the port number and the device that are connected, the device MAC address that are connected are maintained. The table where P0A, P1B, P2C is connected, P3D is connected. This is what we called as MAC table, because this is see, MAC address is actually a big number. For your understanding, I'm writing ABCD. These are all the MAC addresses of this computer. Assume this as a MAC address of this computer. Now, the table that has got this port and the MAC address mapping, we call it as MAC address table. The table in which you have this mapping, port number and the MAC addresses, we call it as MAC address table. MAC address table. Now, this MAC address table is not maintained in hub. You cannot do unicast. You need to do always broadcast. Unicast means what? Talking to the right person and speaking to him. Broadcast means what? Just shouting to everyone. Let's say you are a class teacher. You are a new school class teacher and you never learned any name before. This is the first day of your class. You are entering into the class and you want to tell something to someone called Geeta. Someone met you on the road. Miss, are you going to 8th standard? You said yes. Are you a class teacher? Yes, I'm a class teacher of 8th standard. Miss, can you tell Geeta that father is waiting in the office room? Now you don't know who is Geeta, but you are first day in the class. You are going to go to 8th standard, and as a class teacher, you are just entering the class. This is the first time. You don't know who is Geeta. What you will do? You will broadcast. You will get into the class and say, Geeta, who is Geeta here? Go. Someone is waiting there in the office room. But now you know Geeta, because when you say who is Geeta, Geeta is getting up and saying yes, miss. Then you see the face now. Now you recognize the face. You are learning the MAC address. You are learning the face. Geeta means this is how she will look like. Next time when someone says, miss, please tell to Geeta that today the auto rickshaw will not come. So you will not shout now in the classroom. You will go to Geeta, because you know Geeta now. She is sitting in the second row middle. You will say, Geeta, your auto rickshaw will not come. You go by walk. That is what. If you don't learn Geeta's names first time, you need to again do what? Broadcast. Second time also, if you don't learn Geeta's face and name, again you will broadcast. Hub is like that. It never learns the names of the device that are connected, so it has to do broadcast every time to everyone. But bridges are intelligent. They learn the names. When A wants to talk to C, the packet from A is coming. The data, the packet, has got the address there, source address. Me, A talking. To whom I am talking? I am talking to C. That's the destination. When this packet hits the port, it learns that there is someone called A in port number 0. It learns this line. Initially, this table will be empty. Initially, you are a class teacher who don't know any name. You are just entering into the class. No name. You don't know anyone's name. Slowly, as you take attendance, you started learning names. And then you will talk to the particular person when you want to talk to that person. You won't simply broadcast. You won't shout in front of the class. If you want to talk something to a particular person, you know the name and you know where he is sitting. So see now, this device bridge, it wants to send a traffic to the destination called C. But there is no information about C. There is no information. So what it will do this time, it will do broadcast. It will send to everyone. Now B is receiving the packet. B is receiving this packet. B will check the destination address. Is it given to me? No. B will reject the packet. C will receive the packet. D will also reject the packet. Only C will receive the packet. Now C needs to reply back. C needs to reply back. What will be the source and what will be the destination? C is replying back. Source will be C. Destination will be A. Now when this packet hits the port, P2 C is learnt. How? The source address is always copied against the port. Like it learnt it was empty. When A first sent the traffic, it was empty and it learnt A from the source of the packet. The MAC address will be learnt. Correct. That is how after a point of time, when everyone talks to everyone, you will see that all the MAC addresses are learnt in this table. Yeah, first time, whenever every device sends the first packet, from the first packet, the MAC address table will be updated. From the second time onwards, they don't send it as a broadcast to everyone because switch knows who is connected where. When A wants to talk to C, packet goes directly to C. How? Yeah, second time, because bridge knows that P2 is connected to C. So now let's look into this return packet. Return packet, what is the source? C. What is the destination? A. Where is A? A is here. A is in P0. So the packet can go directly to A. It will not go to everyone. It goes directly to A. This is how bridge can avoid broadcast. So the drawback of hub is what? Hub always broadcast. If A want to send something to C, it goes to everyone. There is no secret here. A wants to send to C, it goes to B, it goes to D, it goes to everyone. There is no secret. But in bridge, if A wants to send to C, first time it will go to everyone. From second time onwards, it will go straight to C because they learn MAC address. Now, which one is good? Bridge is good or hub is good? Bridge is good. Yes. Very good question. Only A MAC address will be learnt. Only A MAC address will be learned the first time when A talks to C, when A send a message to C, only A MAC address will be learned. All the other MAC addresses will be learned when they talk. See, when A is talking to C, C is talking back to A. When C talks back to A, C MAC address will be learned, not B and D. If B will talk to someone, then B MAC address will be learned. If D will talk to someone, then D MAC address will be learned. Correct. You're right. You're right. The sender's MAC address, we can call it a source MAC address. Sender and source both are same, right? So source MAC address, sender's MAC address will be learned. You're right. Now, bridges, because they learn MAC address, they can handle more traffic. Hub cannot handle more traffic. Why? See, hub, if A is talking to someone, it goes to everyone. If D is talking to someone, it goes to everyone. So there will be always in this box too much of crowd, congestion, too much of collusion. So this box cannot tolerate if you keep adding more device. So maximum number of port hub supports is only 8. The reason is hub don't learn MAC address. They don't learn MAC address. So the number of ports in a hub is limited to 8, because if you keep adding more devices, if you have more port, then more device, more collusion, more congestion and more problems. So hub don't support more than 8 port. Whereas bridge, because bridge learns MAC address. Yes. Your question? No. Bridge can have more number of ports. The reason is, once they learn the MAC address, they don't broadcast. They don't cause more collusion. See, you have, okay, maximum number of port is 25. See, you have, you are the class teacher of 8th standard, and the students are too much talkative, always talking. When you joined this new job, the school principal said, see, you should not scold any student. If they are talking, don't scold them. Allow them to talk. If you have 25 students, then you will not go to school next day to teach. If it is 8 people, okay, somehow you will manage. Why? 8 people are not causing much noise, but when 25 people are always talking like that, it is more than your toleration level. 8 is the maximum, let's say. 8 people are talking, 8 students are there in class. Maybe if you take one Saradan or some tablet, you will be all right by the evening. If you have more than 8, even one Saradan will not be enough. 2-3 Saradans you need, and next day you won't get up from the bed. Same story. When every device talks to every device, then this box is like you, class teacher. It cannot tolerate more traffic, because always broadcasting everyone, more collusion. So they said, okay, let us not add more device and make things more complicated. This device cannot tolerate. This device will not support now. It will stop functioning. So they made it as 8. But here, not everyone is shouting to everyone. There is a rule in class now. In bridge is like, you are a class teacher, you are new joinee, you have newly joined in that school. Principal is saying, if students are talking, don't scold them, let them talk. Now you got an idea because you are a clever teacher. You are bridge, you are not hub. Hub is on dumb box, bridge is clever. Now you go to class and say, hey guys, you are all allowed to talk, you are free to talk, but Sita, if you want to talk to Rani, you go to Rani straight and talk. Don't shout in class. That is the condition. If you want to talk to Rani, you can go very well to her place and talk to her. But you cannot shout from your place. She is at the back, you are in the front row. You should not shout. You can go to the back bench, talk to her, come back. And that is the rule that you are setting in the class. Now you can handle the class even with more students. Because not everyone is shouting from their place to everyone. That is how bridge can tolerate more, so it can support 25 port. The reason is they can talk one to one, not everyone. If A wants to talk to C, it can go directly to C because it maintains the MAC address table and it knows where is C. If A wants to talk to C, packet goes to P0 and from P0 packet is forwarded to P2 because C is connected to P2. There is no need of shouting from first bench to the last bench. I know where is Rani sitting. I'll go to Rani and talk to her. When I do like that, I'm helping my teacher. Who is the teacher here? The bridge, the box. It can handle more traffic now. Because there is no much broadcast or no much collusion there. Right. There is another device called switch. Switch, maximum, there is no limit, but for your understanding I want to say switch can support 100 ports. But truth is, more than 100 we have in industry today. Because of virtualization you can do more than 100, but I'm just giving you a big number. Switch has got more number of ports. How is it possible? In a classroom, everyone is allowed to talk to everyone, same like bridge. But you say to Rani, you can talk to Sita, but you cannot shout. Same procedure applies even here also. Switch also learns MAC address. Switch also maintains the MAC address table. It maintains the MAC table. Then how switch can support 100? How this bridge can support only 25? Both are same, like, both learn MAC address. Both are allowing to talk. Unicast is allowed. They learn the MAC address. Once they learn the MAC address, they don't broadcast. All those things are same like bridge. But switch can support 100 ports. How is it possible? It is like this. What they do, Now 100 means what? 100 students in the classroom. How you manage? When there is only single teacher in the classroom, he can support only 25. So what I do is I put 4 teachers for one classroom. That is what switch. 4 teachers, meaning one switch only, but 4 processors. More processor, more ports can be handled, more traffic can be handled. Correct, no? if I put more teachers to the same classroom, then you can have more students. In the bridge, you have only one processor to control all the traffic, only one processor. See, like you have processor for the computers and laptops, you also have processor for your switch. Now you have one processor in switch, but more assistant processors, we can say. Here in technically we call it as application specific integrated circuit. You heard about this in college? Okay. Application specific integrated circuit. This is like processor. This is not actually processor, but this is like processor. When you have this, it is like having more assistant teachers. You have one teacher in classroom and you have more assistant teacher to control students. Then you can have easily more students. The teacher is only one because it is one classroom. But when you want to have more students, what you can do is you can have some assistant teachers who will control the students when you are not able to control as a single person. You cannot pay attention to all 100 people. One single class teacher cannot do that. So what you do is you have some 4 groups, and for each group you have one assistant teacher. So likewise, you have ASIC chip, ASIC, a hardware. It's a hardware component. It's a hardware component. It's a hardware box, small chip, which makes the switch to support more traffic. Because you got more chips, more traffic can be handled. Now, because you have this more number of ASIC, this is called as hardware based device. Switch is called as hardware based device. Bridge is called as software based device. Software based device. Why bridge is called software based device? This is also hardware. It has got one processor and it has got one box, same hardware only, but it has got the operating system to take control of everything. So who is taking care of all the operations in this box? It is this operating system. So it is software based device. Software is in control of everything. Whereas in switch, software is there, but hardware is in control of everything. You got hardware components called ASIC, which controls the traffic. Right? So this is what makes switch and bridge difference. Sometimes some people ask this question in interview. What's the difference between bridge and a switch? Simple. Bridge is the software based device, switch is the hardware based device. That's the main point. Second point is switch can support more number of ports than bridge, because it has got ASIC chip. Yep.